Can hear us now. So welcome everyone and thank you for joining us today. I'm Jelena Cerar, Assistant Professor at WU Vienna, and I will moderate today's webinar. It's wonderful to have almost 750 registrations for the webinar, what we heard today. So thank you all for the incredible interest. Today we have four distinguished scholars with us, each unquestionably a leader in the topic they'll speak about. So first of all, we have Raj Choudhury from LSE, who will talk about machine learning for information extraction. Then talking on a similar topic, we have Milan Miric from University of Southern California Marshall School of Business. He's going to talk about LLMs for information extraction. Then from the same university, we have Nania. She's going to talk about machine learning for causal inference. And last but not least, we have Rita Katila from Stanford University, who is going to talk about machine learning for matching. So in the next 90-ish minutes, we'll explore not only what these methods can accomplish, but also how they're changing the way we do research, let me say it like that, and also decision making. We'll start off with this presentation, which each will take approximately 10 to 15 minutes, showcasing the breadth what AI can do as a research method, and then we'll wrap up with a Q&A part of approximately 30 minutes. Now, you will be able to ask questions. You can see down kind of on the right side Q&A. So please do not write in chat, write in the Q&A, and I will read it to the panelists. And the only thing I still need to mention is that Raj needs to leave earlier today. So Raj will present first. And then after you're done with the presentation, Raj will have a very short Q&A, so 1 to 2 questions that you can still ask. So please free also during the presentation, I will simply choose 1 or 2 that I think fit best. So with that, let's dive straight into Raj's presentation.
Thank you so much, Elena. Can you see the slide and hear me?
Yes.
Yeah, so thanks for organizing. Thanks everyone for joining. And I'm really sorry that I have to leave early. I'm teaching right now. I'll dive right in and I'll take about 10 minutes to cover my material, and then hopefully we'll have a few minutes for questions. So what I'll do is I'll quickly go through a couple of the older papers that I published, just in case some people haven't seen it yet, and for some people this might be repetition. But then I'll talk about the more recent stuff that I'm working on and the field is working on. So the first paper that we published on the topic of AI and machine learning as a method was published in 2018. And in that paper, we utilized a multidimensional data set, a collection of CEO interviews published on the Harvard Business School website. And we used multiple machine learning methods to code communication styles. So the methods, just to recap, and some of you might be familiar with all of these methods. Some of you might be learning these methods. So we use topic modeling to extract meaning from the text. Topic modeling is it's an unsupervised natural language processing method, which I'm sure many of us have used now. We used sentiment analysis, which is now a very well used method. But in 2018, we were a little ahead of the game when we used supervised machine learning to code emotions on facial expressions. And then what we did in this paper that was published in SMJ is we combined all this data and used clustering to create CEO communication styles. So we used factor analysis to come up with different styles using these 3 sources of data: the variance in topics, the sentiment of text, and the facial emotions. And then we correlated those styles with some outcomes just for descriptives. So that was the first paper. The second paper that I published with my former doctoral student, Ryan Allen, essentially was on the topic of using supervised machine learning as a pattern recognition tool. And the thesis of the paper is very simple, that when we do regression analysis, we might miss patterns. So if you are an inductive scholar and you're not testing a hypothesis, you might miss patterns in the data. So there might be a nonlinear relationship between your independent variable and dependent variable that you may not know about and prior theory might not have suggested. Machine learning is an excellent tool to find those undetected, unknown patterns in the data. So that is the thesis of this paper. And we illustrate in a very sort of learning together sort of philosophy, all these methods of supervised machine learning. So I'll skip. I don't have time to go through all the steps of doing this pattern recognition. You can read the paper. We talk about multiple machine learning algorithms such as decision trees, random forest, neural networks. We provide advice on how to select the right algorithm for your study based on how much data you have, how much holdout versus actual data you can use. And then we provide a summary of the visualization techniques that you can use to identify the effects. So how do we know what is the predicted effects? So here we say, and how valid and robust these predicted effects are. So in summary, what you have to do is you have to establish that the predicted effect is robust in both your training data and in the holdout data. And the ROC curve, the receiver operating characteristics curve, is one of the way you can show that. And then we also provide guidance on other visualization tools such as partial dependence plots, which I find very useful to show these effects. And for instance, if it's a nonlinear effect, you can use a two-dimensional partial dependence plot or a heat map to very nicely visualize the nonlinearity. So I don't have time to go through any of these in detail. Again, you can read the paper. In my final few minutes, like 5 minutes, I guess, and then one thing we do before I move on to the more recent stuff that I'm working on and the field is working on, in this second SMJ paper, we provide a very important table in my view, which is how to do these methods, or how to use these methods robustly. Because just like we want to be careful in doing regressions or qualitative analysis, we also want to be very careful that these patterns that we are presenting using machine learning methods are robust. So are they robust to different cuts of the data between the training and the holdout? Are they robust to the choice of the algorithm? Are they robust to hyperparameters tuning? So have you tuned the hyperparameters accurately? And so this is the table 1 in the paper, which is very important for anyone using these methods, or even reviewers and editors who are currently reviewing and editing articles using these supervised machine learning methods. So in my final few minutes, I'm going to spend a little time on agentic AI, because I think agentic AI or AI agents are going to be a very useful methodological partner rather, for our research. So my own work on this, I have an ongoing experiment where we ran an experiment uh, where where employees in a company were asked to they asked questions, and the answers came from their own CEO or an AI agent pretending to be their CEO. And in that study, which we're currently revising, we found that they could not distinguish between the human and the AI CEO. And so the bot passed the Turing test with flying colors. We found evidence of algorithm aversion, which many of you might know. But why do I bring this up? Because now we have quite a emerging literature on what's been called silicon sampling. And there's a very nice paper that Vanessa Barbano and Natalie Carlson at Columbia have just published. I think it's probably accepted in SMJ, where they show that these AI agents can be used in our research. They can either replace or complement human surveyors, for instance, or they can act as experimental subjects in our in silico experiments. And so there's a whole mini literature now emerging in strategy, but also in economics and computer science on what's been called silicon sampling, where the researcher can create any number of AI agents. These AI agents can participate in experiments. These AI agents can take surveys, and they can act as what has been called the laboratory rats for strategy research or international business research. So if you are a researcher with a limited budget and you cannot reach a large number of human subjects, you can create a large number of AI agents to participate in your surveys or your experiments. And so that's where I'll stop. And I think you should read this very nice paper that Vanessa and Natalie have just published. I can, Jelena, over to you.
Yeah, thank you very much, Raj, for your insights. So now we are open for 2, 3 maximum questions to Raj. I still do not see any open questions in Q&A, so I guess we just wait for a few moments, or people are just waking up, I guess, in some part of the world, or a little bit sleepy in the other. So let's see. Yeah, I have a question. If you're going to get a recording of the webinar, yes, the recording will be available after the webinar. Question is if you have some questions for Raj before he leaves. One person is asking if you can get the citation of the paper that Raj just mentioned now. So that is one thing. I will read. We have 2 more questions. So we have 2 more
I can add
questions.
the citations to the chat. Yes.
Wonderful, wonderful. Then we have a questions. What are the reviewers' common objections? And wouldn't the silicon samples be biased based on ethnicity, sorry, and other things? So these are the 2 questions for you.
Yes. So I think the very short answer is robustness. That whether you're using supervised machine learning to find patterns, whether you're using AI agents to conduct a survey, whether you're using AI agents as in silico participants in your randomized control trial, you need to show that you've taken utmost care to establish robustness of any correlations or causal patterns that you determine. And what that robustness is differs based on what you have done. So if you're using machine learning for pattern detection, then it's about hyperparameter tuning. It's about using multiple algorithms to establish the same pattern. It's about doing the division between the training and the validation data set in a very robust way. If you're using AI agents to conduct surveys or experiments, you need to show that you've taken utmost care in training these AI agents. If you're ascribing a certain personality, you need to be transparent about what personality these AI agents are taking on. So as much detail as you can provide in the methodology section would help reviewers and editors buy that you have done it in a robust way.
Thank you, Raj. Maybe just a follow-up question, because it directly goes into that direction, and somebody's also asking, wouldn't that be unethical?
So it's being used. I think silicon sampling is now a legitimate methodology. And I think as long as we are being transparent about how, so just like I think at some point, probably there'll be some IRB kind of regulation around using these silicon subjects, just like we have regulation around human subjects. But, uh, that's for the field to decide how to ensure sociological uh, monitoring over these kinds of new things that are emerging.
And maybe, I mean, there is one more question. We have 1 more minute, so they were fast. Have you had any difficulties to publish papers based on AI models or LLM?
Initially, yes. When we were working on this in 2017, 2018, it was a small group of people. But now I think in strategy and IB, we have lots of people, and Nan has been a great leader in sort of curating, the community, Nan and also Milan. So I think now we have lots of people, young scholars, doctoral students, assistant professors, who are very conversant with these methods.
Wonderful, wonderful, Raj. Thank you very much for your insights. It's a pity that you can't stay longer, but we thank you very much for everything that you shared with us. And we are sure we'll have more opportunities to talk to you about this topic.
Thank you so
Thank
much.
you. Thank you. Then let's continue now with Milan. Milan is going to talk about LLMs for information extraction. So Milan, the floor is yours.
Okay. Can you hear me and see me well enough?
Yes,
All
all
right,
good.
perfect. Thank you so much. Thank you for inviting me to participate, and thank you for organizing this. So what I want to talk about is, I think, very much starting from where kind of Raj left us, which is all these tools that are kind of emerging allow us to do a lot of things that we weren't necessarily doing before. And I think these are great innovations that have enriched what we have kind of been able to do. But I think the popularity of a lot of these AI tools has kind of come with the popularity of LLMs. And so I think it's very often we, as the people on this call, would have a very specific definition when we start talking about AI and start talking about research tools. But if you go, outside and even among the faculty, when you're talking about like what is the impact of AI on learning or research or whatever, most of the time people are thinking about things that they're doing with LLMs, right? And I want to talk about what we can do, but to do that, I want to kind of just go back and tie into what Raj was talking about, which is like, what have we been able to do with a lot of these kind of predictive statistical models that aren't necessarily large language models, right? And so, they've allowed us to estimate models more precisely, greater flexibility, all these things about nonlinearity. When you think about kind of how many things do we believe in the world really happen in a linear fashion, probably very few. If you look at kind of studying, regression models, et cetera, most of the time we end up modeling them linearly for a variety of reasons that have to do with the ease of the method, rather than that's exactly how we think the world works. It's often sometimes really difficult to say how well is a model performing, how well are we explaining, and then a lot of the stuff that Raj talked about within machine learning, it's actually really quantifiable. So we can, understand, are we doing a good job? Are we doing a bad job? And there's really kind of precise methodologies that exist. And to the other example of robustness, being really transparent, showing that like, here were the 15 different ways to do this. Here was the one that was best. Here's why I think that was best. And so there's a lot of these things that these models allow us to do. And I think in the future, we're not only thinking about econometrics when we're writing quantitative papers, we're also thinking about kind of econometrics enriched with ML. So using ML to create variables, to measure things, to select variables, to demonstrate robustness and all these other things. And so I think, from 2017 until today, we've had this huge improvement in terms of how much we can use these statistical tools to kind of do a better, more robust job with our research. And then there have been these kind of deep AI tools. And what I mean by that is a lot of the tools here that we're talking about are tools that are machine learning, but it's a random forest. It'll still run, you can probably do it with the Stata. It's a little bit better with Python, but you're not really using anything like GPUs. But at the same time, because prior to large language models, one of the really kind of most hot areas in terms of kind of deployment of AI was within image and video. All of a sudden, we had a lot of really easy to use image and video tools that previously were not kind of easy to do. So it used to be really difficult to process these things. All of a sudden, we're starting to have greater and greater access to these tools through GPUs, right? So there was more and more ability to process video came out, and then there were papers like the first paper Raj was talking about, where they were able to extract information from video, which was really kind of revolutionary. And then even some of these earlier textual models that we had, so things like transformer architecture, so the ability to kind of create text embeddings and the ability to use those text embeddings easily, right? These were all things that have kind of prior to large language models emerged and have made life so much easier. And in the sense that, previously, if you think about, we wanted to do something with, there was a new model coming out in Stata and a new package, you'd have to buy new software and do all these things. And, in this sense, we had access to kind of, people would train a transformer model, they'd make it publicly available. You could use that in your research almost instantaneously. You would have free access to kind of cloud computing through Google Colab and things like that. So the amount of progress that we've made with being able to use AI tools in the last couple of years has just been incredible within our research and the ease with which we've been able to deploy this. But none of these things have been LLMs. And then I think, this allowed us to do all these things that I was talking about. It was cheaper. They didn't reason, but we don't want reasoning. We want it to do something predictable, deployable, reproducible. And all of these models were great, but they had one constraint, in my opinion, which was we had to rely on data that we already have. So we had to have videos that were relatively predictable. We had to have text that was relatively stable. And, the models, what AI has done so far has been great, but I think the big constraint that we've had was what we could do with the data that we had. So we had to have data that was relatively stable and relatively predictable. And so when LLMs come around, everybody kind of wants to do everything now with an LLM. So there's this kind of idea to say, like, could we, can I give an LLM a paper? Can I give it tell me what regression to run, tell me how to interpret the regression, tell me what other variables to include, whatever. And I don't think this is the direction that we should be going. But if you believe my premise that while AI, meaning ML and kind of deep learning tools have enabled us to do a lot more research, or have enabled us to do more with our data and with our research than we could before. And the one constraint that we're running into is we can only do that in places where we have very consistent data. Could we then use LLMs to make our data cleaner and more consistent using the toolkit that we already have, being able to apply it to a new set of data instead of kind of saying, let's just use this black box tool for everything. And so ML tools are really powerful, but we need appropriate data. We need data that's feature rich, which means it has a lot more information than it has noise, right? So if you look at financial statements or CEO speeches, there's a lot of things in there that are noise, but there's also some really important information. And so can we kind of synthesize the data to extract the important information? We need documents that are comparable length. That's one reason why patent documents and text documents like publications are used, because they have abstracts. And in those abstracts, signal outweighs noise. And so there are some data sets where we have this that meets these constraints, and that's really where we've had a lot of research, the things like patent data. But in situations where you don't have patent data, where you don't have those conditions, where you don't have stable data, where the data is kind of different length, so sometimes it's really short, sometimes it's really long. Like you can think of, set statements that people make or things like that's one reason why people like Twitter is there's a limit, but there's not too much variation in how long the text is. If you have really long text documents, that can sometimes be a problem because the amount of noise relative to the amount of information is very large. And then sometimes you have documents where only a small part of the information is relevant, but you want everything. And so we typically have trouble applying our, ML models to those contexts. Can we use LLMs to improve this process? And so if I think about what LLMs do really well, they synthesize text and they extract information. And so instead of asking it, can you classify data? Can you do all these things? We can ask it to create a summary, extract the key information. There's a super long document, extract the key information for me and allow me to kind of analyze those things. And also, we're going to think about, can we ask it to construct measures of relevance in the same way that transformers have this kind of embedded knowledge to say, like, look, these two things tend to co-occur in the same space, and those two things don't. Can we use that from an LLM to get a sense of something where we might have had trouble before? And I think it'll be clear what I mean by that as I move forward. So to kind of explain this, this is collaboration with Nan and our doctoral student Albert. We've been working on this idea of like, could we kind of apply this to the idea of looking at how government regulation impacts companies? And one area where this is hotly debated is tech companies. So can we see if we can establish kind of a link between those? And so, there's this constant debate about kind of tech being subject to government regulation. There's a lot of information on public record, but it's long, convoluted. And like when we take a step back, it's often not clear what is the policy position, right? You can point to an anecdote where somebody says that like privacy is good or privacy is bad. Like, some people will say, Facebook is selling your data. Somebody else will say probably Facebook. Nobody cares more about your data than Facebook. And so like there's this tension between like what is the actual policy position of the firms, what is the policy position of regulators, and what are they talking about? And I think the reason that this is difficult to do is because we can easily find anecdotes, but it's really hard to systematically go through and clean out all this data. And so what we're talking about there can be kind of a methodology for doing this type of thing. So the first step is to take these really complex documents and summarize them into kind of clean, short, concise, information-rich documents, understand how policymakers are thinking about an issue. We can go to congressional hearings. There's all these people that they bring in and kind of, pull out information like how much are they thinking about technology as something that's going to be a source of innovation versus a threat. So things like privacy and consumer protection, right? And so we can use LLMs to parse the document, create specific summaries. We can validate the summaries, as we can talk about in a second, and then we can create almost like patent abstract, short little blurbs that summarize in an information-rich way what is happening that we can then use to apply the other ML methods that we have. And so we did this across a large number of congressional hearings. And so you get these LLM summaries, but the problem is that like you now need a human to read all these short summaries to validate them. One thing that we can do is we can look and say like, okay, well, I don't exactly know how good the summaries are, but if we're doing a good job, we'd expect the summaries that are kind of within the same committee or within related committees to be more similar than the summaries that are off about something else. So if you look here, for instance, like, there's a government committee that discussed like the Army, they discuss foreign affairs, and they discuss, kind of select intelligence, so spying and whatnot. And there tends to be a high correlation between the documents within those. So within groups, there's a high correlation, and also across related groups, there's a higher correlation. But there's much less correlation between, Army issues and education in the workforce. And meanwhile, there is an overlap on other things. So we see within committees, there's a lot of overlap, and within related areas, it's overlap. And this is kind of a sanity check to make sure that our text summaries are somehow consistent when, we'd like to believe that they are, but we don't have a kind of common way of quantifying this. The other thing that we could do is we could say, okay, well, why don't we look at like, summaries created off the same document? How similar are they? So we can do a sanity check and say like, okay, are these LLM summaries hallucinating? Are they creating random things, or are they creating kind of relatively similar summaries? And we find within the same kind of document, so they're discussing the same issue, there tends to be a high amount of overlap between summaries generated. So this is like one check that this is doing a pretty good job. We can also see, as you mentioned, like within the same committees, there tends to be a high degree of overlap. And then within different committees, it goes down. So this is like another sanity check that we can do where we're creating synthetic data, but we can try to work with and say, is that data somehow consistent with what you would expect? The next thing we can do is once we have these summaries, we can go and kind of, you're not asking an LLM like, hey, tell me what the US Congress is thinking about this issue, but you're giving it a text and saying, what are the top issues coming out? So it's almost like topic modeling, but you're kind of allowing it to maybe create various keywords that come out, and then you can work off of that later. And so we're giving those summary documents and saying like, okay, what are the opportunities being discussed? Like when people are talking about technologies, what are the positive forward-looking things that they're trying to kind of say will come out of this technology, and what are the things that they're kind of worried about? And so we provided the documents, we ask it to say, what are the main opportunities, what are the main concerns? And then we can look and say, well, okay, what are the issues being discussed? And so, when we look at tech regulation, we see in terms of opportunities, they're thinking about privacy enhancing, public-private partnerships, having a legislation that applies everywhere, not just in specific geographies. So these are really the big opportunities that they're focused on. Very few people are interested in ethical big data and things like that. Responsible AI is way down here. Meanwhile, when they're talking about concerns, they're talking about concerns about like data exploitation. So people stealing your data, and using that kind of in a let's say, like in a way, if an insurance company had additional data or a marketer had kind of too much data about you, and things like cyber attacks, et cetera, there's much less work on like AI bias, or much less concern about AI bias. And I'm not saying that that's good or bad. I'm just saying like without this method, it'd be really hard to quantify this. And this is the kind of information that we're able to extract and hopefully have a new data set that can also then answer additional questions. And you can also see kind of the flow of debate on these issues. So early on, there was a lot more concern about kind of government having too much kind of influence on people's private data, whereas the pace of kind of technological innovation has not really kind of spiked in the same level. Some might argue if we looked at more recent data, this would probably be spiking up here. But we're able to trace this in a way that really kind of wasn't super easy to do before. And then the final thing, while these results are interesting, so they provide descriptive information that we had a hard time quantifying. So we didn't know which issue was the most important for tech firms or for government, et cetera. That doesn't really translate into like a research method or research question. But what would be kind of useful for research is if we now looked at these issues and said, look, here's what policymakers are talking about, which firms are actually being affected. If you imagine there's like a policy, there's a regulation, who's treated and who's untreated by this policy. And so one thing we could do is we could look at company 10Ks, which tell us something about what the firm is doing. We could look at the policy that's telling us what the firm is being concerned about. And there we can kind of use an LLM, as I was mentioning, in this kind of space to say, like, are these two things close to each other or are these two things far from each other? And we don't know how good that will work, but when we tried it, or how well that would work, but when we tried it, what we found was, for instance, the tech regulation had a high impact on firms which were in the, communications 2-digit SIC codes, whereas it had very little impact or very little relevance for like metal mining, leather production firms, and tobacco. And so this was like, we don't necessarily know how to validate it, but when we look at something like this is like a sanity check. We see that the firms we think are likely to be affected by this policy are super affected. So these firms over here, if you can see my cursor, whereas the firms that are not affected. And so all of this suggests that these are potentially very useful methods and very useful ways for us to keep the methodologies that we currently have, but enrich the data sources with LLMs, standardize the data sources. And I think, very much in what I think Raj was a perfect introduction to all these things, because I think all these methods that you've published on that you're talking about are going to have so much kind of more impact as we move forward and get better and better data. And I think of this LLMs as enriching data, not replacing these tools. If you think about it as like a cheap, reliable RA, or a situation where you could put multiple RAs to do the same thing and like send them to the library and have them, read a bunch of dense text and create like a short summary, you can do that at a scale that wasn't possible before. And that's going to enable you to do a lot more than what you were doing before. And so that's kind of my take on how we can use LLMs as a research tool. I'll stop there. Happy to answer any questions.
Yeah, thank you very much, Milan. I see that you already have the questions, but we're actually going to address all the questions afterwards when we are done with the other two presentations. And also, please, when you write the questions in the Q&A part, always start by naming the panelists you'd like to direct your question to, that it's easier for me basically to spot who you want to ask the question, or if it's for all the panelists. So thanks again, Milan. We'll continue now with Nan. Nan is going to talk about machine learning for causal inference. So Nan, the floor is yours.
That's great. Thank you. Thank you, Elena. So Raj and Milan's discussion are a great segue into what I'm trying to introduce, and probably what Rita is going to try to introduce as well. And so they have showed us multiple creative, great ways of extracting information more thoroughly and more accurately and more efficiently. And then we do things with this information. For a lot of us, we take this information and we want to actually understand causality. We want to understand A causes B. And what I would like to discuss today is that machine learning methods not only will stop short of giving you the information you need for the next step, let's say it's in causal inference, but it itself can actually enhance the causal inference. So I'm going to introduce one particular method, which is the causal forest. We absolutely did not develop this method. It was developed by economists. It's being used actually in some other areas in business schools as well. But for us, I think it's actually important because a lot of us look at firms and heterogeneity is at the heart of strategy or even international business. I'm sure that's important as well. It relates to different firms are do different things, and the same thing will generate different outcome from different firms based on different scenarios and all these heterogeneity that enrich our theory. So that is a central task for a lot of our research project. But our traditional or good old regression-based methods, they have issues there. So one of them is matching, but I will leave that to Rita. Rita will elaborate upon that, as you see that I recited her work. And the main pain point with our regressions in capturing this kind of heterogeneous treatment effect is the following. If you think about our what regression is trying to do, it is trying to minimize error, like the difference between your predicted outcome and your true outcome, the y hat and y. And what it's trying to do is to find a best single number that fits everyone's treatment at once. You have one average treatment effect. It's great at doing that. It's average treatment effect. And then when we want to look at heterogeneity, a common method is for us to do interaction terms, right? Or in some cases, subsamples. But in order to do that, let's imagine very simple case like A causes B based, and this effect will change based on C. And if you can dichotomize A, dichotomize C, you have two by two, 4 cells, and you will need at minimum somewhat equivalent amount of observation each cell. That puts a lot of pressure on your statistical power. It also raises it, but then that's a very simplified situation. Oftentimes it's like, oh, it's not only dependent on C, but something else, and there are multiple of such interactions. That's where the regression analysis, which starts by focusing on estimating average treatment effect, and then using the interaction or subsample to find heterogeneous treatment effect, starts to show shortcomings, starts to fall short. And that's also where this method called causal forest actually will compensate for a lot of these shortcomings. And this is a completely different approach in that you do not start off by looking at one single number that fits everyone's treatment, and then you look for heterogeneity in there. Instead, what this method fundamentally trying to do is to estimate the treatment effect for every single observation. So you do not start with everything, you start with every single observation. And is this established by Susan Athey and co-authors in Econ? It has been applied increasingly in the business research, especially in marketing, because a lot of them are trying to predict things like, oh, who should I give coupon to and how much? And I can imagine that's a very individualized question. And in strategy, but the very first related method I encountered is actually Milan's work on random forest. It's still predictive. The goal there is still to predict. It's a predicted outcome, but it's getting closer to this causal forest. And so I want to do an empirical demonstration of how it works using one of our joint projects where we're looking at the Sunshine Act, which is in the US. Physicians can receive payments for various reasons from pharmaceutical companies, and after this act, they have to disclose. So the payments is kind of a dubious nature. Some see it as a problematic. Let me just do this. So some see it as like you're trying to promote their product, and that's not ethical. But that's not the consensus, because a lot of the times these payments are used to gain expert opinion on your innovation, on your drug development. So it's kind of what it is really depends on how you see the nature of this such payment, and that may also depends on what firms are using it. Like say, I'm a firm in trouble. I face a lot of drug recalls. I want a physician, the world famous Elena to promote my product. That you can be seen as that's problematic. But it could also be the case, I'm in trouble. Elena has the knowledge. I need her to help me with this drug development process, and that will be productive. So you can imagine whether this kind of this requirement to disclose this type of behavior or this kind of payment affects whether I'm going to make this physician payment depends on a lot of things. And that's the heterogeneous treatment effect that we're looking for. So we have a bunch of data here. And I want to say, like, this is how we implement causal first. So first is like you're searching for clones for each of these treated observations. So that's not fitting a line in the first place. And then we have an entire distribution of all these estimated heterogeneous treatment effect. And then we're trying to explain where the how to understand the heterogeneous treatment effect. And so let me probably put more of the stage 1 and stage 2 here. The goal of stage 1 is really just for each of the treated observation, I want to find your clones. And that is not it's not up to the researchers, it's up to this algorithm. So what it does is that it's going to go in there, do it multiple times. It's going to start to split groups. The goal of the splitting groups is to maximize the difference among the groups and minimize the difference within the groups. And it will split a bunch of times. For example, let me take this, and then they will generate a leaf, which is a whole bunch of observations that are clustered here. And how do we understand this? So let's say I'm taking this leaf as example. What does it mean? Is like, is your market value larger than 11, whatever unit that there is? Like yes or no. And then the data finds that when your revenue is larger than 9, then this subgroup are actually more different from everybody else, but it's very similar among itself. And then the algorithm finds that if your patent citation is larger than the number, then that's a threshold. So this process is not sort of driven by any theoretical guidance or human intervention. It's just algorithms like let the data tell me where the biggest heterogeneity comes from. And you will do it multiple times such that you will actually, for each observation, you will have a estimated treatment effect. And that would allow us to draw a distribution. So let's look at everybody and then where does the treatment effect look like? And so therefore, this is the distribution of our individual treatment effect. So what it says is that this is 0, like it means like no effect. After Sunshine Act, it doesn't really, my payment to, as a pharmaceutical company, I say this is actually, yeah, I'm putting it later, my payment to physicians does not change. But then you can see that for some of my peer firms, the effect is negative. They reduce payment, but there are a whole bunch of other firms, they increase the payment. So this is the heterogeneity that is underlying the effect of this law on physician payment. And you can imagine that if this distribution is very tight, it's like imagine this very thin, the long a curve around a single value, then that's your very much credible. That's your average treatment effect, and you may not need to. Maybe our traditional regression-based analysis, they're able to capture this reasonably well, and we do not need to mess with heterogeneity. But in a lot of other cases, as you've seen here, is very dispersed. If we're only looking at the mean, it's not that much different from 0. And maybe if we only care about the average treatment effect, your conclusion is that might be that this law had pretty limited effect on physician payment, but in reality, it is not, because things vary a lot. And there are ways to verify this, whether the estimated treatment heterogeneity actually is valid or not. And this rate is one of these metrics, and what we can also do is to plot this targeting operating characteristic TOC line, where my x-axis are the fraction of units that are targeted based on the predicted treatment effect, like the top 5%, top 10%, all the way to a minimal treatment effect based on the predictions of this model. My y-axis here are the average treatment effect in those units. And if this line is flat, what it says is that the average treatment effect is very much similar no matter which group you're looking at, which group you target. And i.e., there is not much of heterogeneity in the treatment effect. If this line is like this, like downward sloping, very significant in a very significant way, what it says is that the units with the highest predicted treatment effect indeed exhibited stronger actual treatment effect. So therefore, heterogeneity exists. So this is sort of the type of results that this method will give it to you. But then it just show you, look, there's a heterogeneity there. It doesn't do anything else. But for a lot of us, because we're theoretical driven, we have theories tell us where the heterogeneity come from. So in our case, it could be the firm's own strength, the firm's own crisis. It could be a lot of other things. Oh, by the way, before I get there, I want to just also compare that with the regression analysis. This is what we found, what we have when we actually have regression analysis. There's some effect there, but this is just the one number that actually it's in a way, if you compare these two, not quite similar with what the average treatment effect of CS is, but that's not the point. The point is that CS really captures this distribution. Okay, so what do we do with this heterogeneity? And that's where our theoretical guides and exercise all have to come from. So this is like, we believe a bunch of things should explain this heterogeneity. And then what you have this tau head, which is the estimation generated by the causal forest. And then you do a regression to say, hey, is the tau head for every single observation explained by factor A, B, or C? So these factor A, B, or C in the traditional regression-based world will be your interaction, will be a moderator. But here, it is used to see how much of these factors explain the variation in my individual treatment effect. And then, so what do we do from here? A lot of us will stop here because that's the hypothesis testing, and then you're done. It can also be used for policy recommendations. And with that, I'm not referring just to public policy. As the example I was using previously in marketing, they are trying to predict how much, what type of coupon they should give it to everybody. So that's kind of very individualized suggestions, recommendations. Where if you're in our strategy, you can say, consultation has to be a very specific scenario. So the consultation you will give to the firm will be case by case. So there may be opportunities for you to do inductive theory building, which is that we're working here with some theory. We thought, oh, these things matter, but the data tell us, look, the R&D or whatever citation pattern that actually is the main determinant of your splitting. That's something you did not expect, and maybe you should go back and revisit your theory. That could be another possibly going forward. And with that, thank you for your attention, and I hand the baton to Rita.
Thank you very much, Nan. Rita, now before we just start with you, just very quickly that I mentioned, I still see the questions coming in chat. Please address them in the Q&A and start with the name of the panelist, because we'll have a lot of questions at once. So once again, please put them in the Q&A. And now Nan was mentioning several times that some parts are left for Rita. So Rita, we're looking forward to hear about ML for matching. Please, the floor is yours.
Okay, thank you. Hello, everybody. Thanks for joining. So yes, I will definitely work on my to-dos from Nan. This paper that I was asked to present is 2024 SMJ, and it's Jason Rath's, my former student's dissertation work, and Phil Reinecke is also a co-author in the paper. And this paper is sort of one of those papers where the world caught up with us. And so Jason's dissertation work around, this was before the pandemic, around 2018-19, he was taking Susan Athey's class, Guido Imben's class at Stanford, and came to me and said, there are so many interesting machine learning methods being developed in econ, but strategy really hasn't paid attention to causal inference. Is there, what could we look at this? He also had an interest in public-private firm relationships. And so we started talking, so machine learning AI, the way one wants to think about it, basically it's a prediction method. So you would be, in our world, you would be looking at relationships where you predict something, whether somebody collaborates, for example. So that would be a task for machine learning and AI. Very basically, think about the early computer science approach, is the picture of a cat or not? So that's a basic prediction task. So that's where machine learning really excels. Many other applications, sort of more inductive, you categorize things, the very basic idea. So we started looking at, with Jason, first, what kinds of prediction tasks do strategy researchers do? So we went through SMJ, and we quickly realized that propensity score matching is actually a big area with big data. Again, another requirement for most machine learning methods. Yet people have really not thought through what to do with propensity score matching and carefully construct the first stage. So that was the world in 2018-19. Somebody was asking, what did the reviewers and editors think? They had no idea what we were talking about. They were basically giving us reviews back that were literally copy pastes of Susan Athey's seminars online. So yes, so that's a quick answer to that question. So let me dive in. So we're all caught up to the idea. So 2024, we published the paper. It's SMJ, open source. So yes, open access. And yes, there's also a fabulous video abstract to watch, done by AI, of course. So that's the background for the paper. Let me back up a little bit, rewind the world, go back to where I started. So I actually have done research on AI and machine learning for a long time. This dates me. So the first wave of AI, industrial robots. So this was my dissertation. I can't believe I've been doing this for such a long time. Then more recently, Milan mentioned the work on AI ethics. So Ali and I've done qualitative work even in this space. And then most recently, my work has focused on using machine learning as a methodological tool, basically for strategy and organizational researchers. Another recent paper is with Stefan Thau, where we look at, in academic management annals, how to use large language models as tools for, I don't know why this is advancing by itself. Very, very weird. I'm not touching anything. Let's see how this goes. Using topic clustering, trend analysis, relationships. So it's fun, as somebody was mentioning, when after 20 years, I'm coding again with large language models. So give it a try. It's actually a lot of fun. Okay, so now to this paper that I was tasked to talk about. So what is this method? When can you use it, when you should use it, and when not? So let us dive in. So as Nan or Milan mentioned, strategy, if you think about it, it's about complex decisions. We have, as a strategy, as a CEO, there are many moving variables in the world, and the complexity of this is that they're interdependent. So this is a big mess, complex decisions to make. And what we are really interested in ultimately is what is the performance influence, performance effect of making one kind of decision or not. So should I acquire or not? Should I advertise my startup as CSR, as sustainable or not? What are the performance implications of those decisions? So that's where the method comes in. So, whether to collaborate or not, influenced by many, many variables that are also, unfortunately, interdependent. So that's the basic dilemma for strategy scholars. So causal inference becomes problematic. Okay, so these decisions are not randomly assigned. So when we want to understand performance, it's a very basic causal inference problem. We don't have a lab. We can't randomly assign whether a company acquired or not, or whether an antitrust ruling was a good decision, not if you're a policymaker. Okay, so what can we do? So two-stage matching models is a common approach. The first stage is a selection, a second stage is performance, and the first stage here is what many of you could have done before, which is using some kind of matching, and propensity score matching is very typical if you're a strategy researcher, for example. So that's the basic setup. However, the first stage where it's selection, remember it's the 0-1 dependent variable where machine learning is really good, right? So self-selection to any kind of policy is typically modeled by all of us by a few simple ad hoc determinants. And people don't really, as we looked at this prior work, didn't really pay attention how to carefully construct the first stage. Why is that important? Because if you don't do it, the second stage, the performance evaluation may be biased. Okay, so we really tackle the first stage. It's like a foundation for the entire building. If the first stage is not correctly constructed, then the second stage will not give you the right performance answer. So what did we particularly do here? We used machine learning to effectively match 3D to the relevant control group. So we want to make sure that the treatment group is matching. The 3D observation looks exactly like the matching control observation, but the treatment. So this is from our fabulous AI. I don't know if it's exactly right, but it tries to do a good job. I think it somewhat does. Okay, so selection of critical variables, first stage, we try to improve that to reduce bias in the second stage. Okay, so what is this paper on the left? I have research to date, kind of the current state as we saw it around 2020 when we were writing this paper, and it's pretty much there still. And then on the right, I have some ideas for what we could do differently using the ideas from the paper. So research to date, it does emphasize complexity. There are wonderful papers about strategy being complex decisions, but this is not really reflected in our empirics. So we are proposing this for deductive strategy research, this method to assist with the first stage, and machine learning here particularly being a relevant method. Again, to the left, there's a treatment selection bias. So some firms are maybe more prone to acquiring, maybe there are better firms that would then bias the second stage as we are doing the performance evaluation. So we are unpacking this novel machine learning matching method in the paper that then ultimately allows for strong assumptions of inference. And as I mentioned, this is based on meta-analysis of the papers that we were publishing in strategy, like where are the biggest opportunities for this method, and also probably the biggest challenges interpreting prior research. So we are not criticizing anybody's papers, we're just saying, hey, we could see if this method will help. Okay, so what are some of the key decision criteria? When to use machine learning, when not? So should you be, if you have a two-stage model, could you be using the method? So typically when you have the number of variables is much larger than number of observations, and there are variable interdependencies, then you would go to this machine learning. If the opposite is true, go to the left, the traditional two-stage. If there are many variables with complex interdependencies. The other super interesting, cool thing, if you've done two-stage models, you never know whether first stage is correct. How do you use R-squared for model fit, but that really, we all know it doesn't really work to compare across different data sets or across different models. So somebody mentioned, was it Raj or was it Nan, or maybe Milan mentioned that machine learning gives you these measures of predictiveness. Area under curve, AUC is one we use in the paper. We compare R-squared, you'll see in a little bit. Also, another useful thing is regularization. So sometimes you may be wondering how many predictors, how many variables actually to include in a model. So machine learning does automatically prevent overfitting and prune down the list to the best model. So again, we do need, of course, we need researcher influence. This is not an automatic method. Okay. And then, combination of optimization and researcher intuition, absolutely needed. So traditional, we have researcher intuition. Here, we combine the both. Okay, so this is the meta-analysis I talked about. So let me, I know we are running out of time here, so wrap up the benefits of machine learning. So untestability is a problem with our typical methods. So here, one big benefit is that we cross-validate. So we split the data, we train the models with different data sets, then we test them. So that provides an assessment strategy. Of course, you need bigger data sets for this. We talked about under and overfitting. So regularization gives us an automatic method to remove covariate noise. If you've ever been wondering whether you are right, whether your intuition is right, is also computationally tractable. So it's based on optimization methods. And this is just a basic example from the paper. We have different models where we start from propensity score matching, starting from certain variables in model 2, we add more additional covariates. We keep the original. We add more. You want to here look at, just for today, look at the test data. You see AUC scores R squared. R squared is conveniently increasing. Again, third model, we have everything else that we had in 1 and 2, and then we add quadratic interactions. Again, you see R squared increasing, AUC increasing as well. Here, model 4, we add more, we add regularization, AUC increasing, R squared about the same, and then model 5, overfitting. What happens? Look at the AUC, it actually drops. What happens to R squared, our usual measure? It actually increases. We all know that. Add more stuff, R squared increases, but it's not the best model. So AUC gives, this is a concrete demonstration from our data that there are benefits to these methods. Okay, so a lot more in the paper showing concrete changes in the covariates. So I would encourage you guys to give this a try. If you have complex strategic decisions, you're interested in their performance implications, and we're proposing this novel a machine learning matching method for strong assumptions. So I'm going to end with machine learning can help. And if you're an engineer like me, it's so exciting to have all of these new methods that are very relevant for us. I'm turning it back to Jelena for some, I guess, Q&A next.
Yes, thank you very much, Rita. Wonderful presentation. So we already have several questions. I saw, Nan, that you already answered to some in the chat, so we might do them publicly as well. But let me start with the order. So Milan, let's start with you. There are several questions for you first. So first one is actually about how ethical the things you spoke about are. So to be very specific, we have a question. So if I get LLM to provide you with the interpretation to the data collected and analyzed through, let's say, SPSS, will that interpretation be valid and not unethical? Will it be as rigorous as when we do it ourselves? What do you think?
So I think what you're talking about is the thing that I said we shouldn't be doing, which is my idea is you take the raw data that's messy text, use an LLM to clean text so you can deploy it with existing methods. What it sounds like you're saying is using stuff that comes out of SPSS and then having it interpreted. And I think that's one thing that, you should definitely be doing, because I think that's in some sense what your role as a researcher is. So not interpretation. So I don't think it's like an unethical issue. I think I think your role on the project and paper should be interpreting these results, reconciling it with literature, doing all these things. The more that I think people kind of start relying on things like LLMs, I think the more you're getting out of the area, which is like where your judgment is valuable and the LLM can't judge. So the LLM can take a whole variety of potential explanations, it doesn't really do a good job of figuring out which is relevant for the conversation that you're in, which is likely given the context. It just lists a variety of things. And so it's really helpful at organizing those tasks, but I don't think it's helpful at making sense of these things.
Thank you, Milan. Maybe as a follow-up question, we have another one from Gaurav from India. So what he says, I'm working on foreign divestment, and even though as per company rules and act in India, companies have been publishing detailed subsidiary data, both domestic and foreign, in their annual reports, this data is not available on any platforms yet. I have tried extracting data using ChatGPT, but it does not work. Could you please give me guidelines on how to start using GPT to extract this data, which is in the table format, but template varies?
So
Not
I
a
think
simple one.
yeah, so I think in this idea, it's also something along the lines of like, so again, this varies from the part that I'm talking about, right? The part that I'm talking about is you just have messy text and you're synthesizing messy text. In this case, you're trying to take data from a tabular format and put it in a different tabular format, and you're trying to reconcile 5 things. Now, I don't know that I would suggest doing that in the first place, but I think if you wanted to do it, I would use it as a better way of copying the data rather than something else. So I think what it will do is you won't give it a report and say, hey, pull out the information on this table. Like that won't work well. But if you were to like copy in a table and say, make these information accessible in a way that I can pull the data out easier, right? So like making an Excel and transferring it over, it will do a better job of. But I think it's a lot of this stuff is, I think, within the realm of like, let me just give it to an LLM and have it create data tables on these things. And this is just, it's a computationally intensive task that is very hard to perfect, and I think it's not necessarily worthwhile perfecting it.
Can I jump in real quickly here? I think there are
Please,
so
Rita.
many different parts of this question. So first of all, is the problem, so what we found in our integrative review piece is that sometimes ChatGPT, the other LLMs maybe too, but ChatGPT, previous versions struggled with PDFs, and they were very good with text files and Word documents. So, that's one there could be different layers to this question. So I don't know in what format your annual reports are, but what I found personally is ChatGPT 5.1, the thinking mode is much better than anything else in this respect. Now, the other thing is, are you trying to get to companies' websites and the annual reports are there, and it's that's where you cannot get the data done. So I think there could be different layers to this question, why you are not able to do what you're not able to do. And Milan had added other things that may be a problem here.
Thank you. Thank you very much, both Milan and Rita. We continue with a question for Nan. It's more like a small request. If you could explain a little bit more detailed problems of difference analysis method again that you were mentioning.
So DID on all the regression-based models, if you think about it, fundamentally is there to estimate an average treatment effect. It is looking for that one single estimate, that beta that actually will explain that best explains everybody's treatment at the same time. And that is a fundamentally different approach from the causal forest that is there to look at treatment at each individual observation. And so when you have the goal is to come up with this one average treatment effect, and then you're going to try to parse it out using interactions or subsamples. Your ability to do that depends a lot on the data distribution in these groups of the heterogeneous group that you're interested in. And the problem quickly compounds when you actually have many covariates. And some of these covariates are depending on other covariates. So a whole bunch of that quickly compounds to interfere your ability to nail the heterogeneity. And it also has the matching problem that Rita actually discussed. I did not too much efforts in there, because in the idea, all of us would know the matching process is a monkey business. You're doing everything, and then a whole bunch of human judgments in there. We don't know whether like all the assumptions, what variables to include, and things like that. And causal forest, the quote unquote matching of causal forest does not need any human judgment in there. It's like the data shows us this is the closest clone, for example. So two aspects there.
Thank you very much, Nan. Now we go with one question for Rita. Rita, could you please explain metadata volume and style on your presentation? How could you do cutoff data volume for learning model steps and final analysis? Please, if you could explain methodological rules on this issue. This is a question from Orkun.
I'm going to interpret this question as how big of a data set you need, and then how do you split the data. So in our case, we are talking about thousands of observations. So if you have a small data set, probably the cutoff is thousands, tens of thousands. But we have a lot of that type of data now as strategy researchers. So Abhishek, for example, Nagaraj has done wonderful work on some geographical variables where there's economic activity. So you do have thousands of observations. How to split the data between testing and validation. So typical split is 80%, 10, and 10. So we had a huge data set. So most of our data was in the making the model, and we had less in testing. But again, depends on your data size. But these are again questions. I would go back to Nan's point. Listen, a lot of this is monkey business. Yes, we have new measures, but it's still, we have rules of thumb here, like how to split the data, and there isn't really any definite answer. So I think we are moving from one monkey business to another, Nan, here.
Yeah, I think we're trying all to answer some questions that are very difficult for all of us to answer, but the questions are just coming in that direction. Thank you, Rita. Milan, we have another question for you. What is with small language models in the research area?
So I think that this falls under the realm of, okay, so if you think about where these small language models can really be useful, I think that often kind of engineering problems get conflated with research problems. So engineering problems are problems where you need to run something a lot, right? And so you think about like Amazon's figuring out how to put models on, Alexa hubs, and Google's trying to figure out how to put it on smartwatches and whatnot. And that's where a lot of these small models are really effective, and compute size becomes an issue. I think if you were to run your entire data set through some, even high-end LLM, but it can solve your problem, you're actually like at a price point, probably what you're paying for other data sets from third-party providers anyway. So I think there's an issue where you could kind of use a smaller model to solve a problem, but I don't think that model size, and I don't think that necessarily the model differences are really what's going to determine it. I think where you could end up benefiting from smaller, less complex models is when you have really simple tasks, like you're trying to extract certain information, and it's about doing it at scale, or it's about doing an experiment, or it's about doing validity. So you want to have robustness, 5 different models do something. It's often you can get away with using a simpler model because you're checking it, you're doing whatever. But I would treat it in that way, and I would shy away from the research conversation that's like model size compute, because these are important things, but these are important things for engineering, not for research.
Thanks, Milan. We have one question that is not written actually for whom it is, so I guess it's actually for all the panelists. So you can order in whichever order you prefer. It's a question from Andreas. Have you been running your prompts and agents on different LLMs as a robustness test? So whoever wants to start.
So I can start. I can start.
Ladies.
So sorry, Nan. Okay, go ahead.
No worries. Go ahead, Rita.
Okay, I'll go ahead. So with Stefan Thau, we used different LLMs for our academic management annals paper, and they're actually wonderful comparison papers. So for coding, Gemini is best. For, other tasks, our kinds of tasks, ChatGPT is best. So I don't know why you're asking the question, but yes, the models differ. I personally, like I said, ChatGPT 5.1 thinking mode is absolutely best for the kinds of tasks I use ChatGPT for. But you should look at computer science papers that compare different tasks and different models. And of course, this is, I think there was just a new model coming out this week. So I think, was it from Google? So again, you would want to see what the latest comparison is and what the task is.
Yeah,
Thank you,
I
Rita.
think, yeah, I
No,
think
no, please. I
Raj
just wanted to say none.
sorry, Raj, before he left, he referred not Vanessa and Natalie's paper, right? And that one asks you to do this estimation. I mean, like this, you run your prompt multiple times, and maybe on different methods, such that you have a distribution of the outcomes. I think that's what the essence of their method.
Oh, I want to mention one other thing. So there is, what's his name? Frodkin from BU, Andres. He has a wonderful paper on looking at which models developers use. And one of the super interesting findings, he's more of an economist, but for strategy folks, was how the developers sometimes keep using an old version of an LLM. And I started thinking that, they've optimized their data and their models. So, for an economist, that was a surprise. For us in strategy, that's actually something that I think is very interesting, because you would think almost that the model and with your data, that combination might be something that works really well for you. So I think your question is very insightful, and sometimes a model that for some reason worked for you, and the new version comes out and works less well, I think is an interesting question.
Thank you, Rita. I'm not sure, Nan, if you have something to add. If not, Milan, maybe you want to comment?
Yeah, so I think there's a similar, I think just agreeing with what Rita said, I think there's, you often have kind of, it's helpful to test out different models, but I think it's often useful to have a kind of robustness and validate whether the newest one's really giving you something different. And if the older one, it sometimes might be worthwhile sticking with one that works, and that can also make it reproducible. And I think there's this, to Rita's point, there's all these things that we kind of co-specialize around, right? So you learn how the model works, you learn what type of output you get, you learn how you can use it, you have code and certain things built around a certain model, and often you might not benefit from going to a different one. But I think inherently, whenever we're doing something, kind of step one, you're trying to compare different models and see which one works and when.
Thanks, Milan. We come to one more question that is, I guess, again for everyone, because it hasn't been written for whom it is. And it's quite broad, I would say. So we can discuss it a little bit longer, actually. It's how can AI and LLMs be used in a best way by business analysts? It's not an easy one. So just what would you say as some suggestions?
So this is my business analyst. I'm going to interpret that as kind of people working in companies and our students, etc.
Practitioners, let's say like that.
Yeah, and we have this, I'll just speak as like business analytics program that I'm involved in. I mean, I think ML is a key part of the data skills that they're getting, so I think that's definitely an issue. I think in terms of LLMs, my personal opinion is that, and so this is not validated, but this is like where I think things are going, is that what LLMs are going to do is they're going to make certain things easier to do than ever before. So like typically where business analysts struggle is that they can do certain things with like data, but they're not great at necessarily making a product or prototype, and they have to therefore interface with a engineering team. I think in the future, people are going to be able to use things like no-code tools a lot more to make their own prototypes. And so I think you could have business analysts kind of like both developing the thing that's going to collect the data, then collecting the data, then analyzing. Then if they have an idea, they can start interfacing along. So I think that's one area where I see LLMs really having a huge impact, is this ability that like you can give, text instructions to a model and it can make a thing that then goes and makes an app or makes a website or does something. So like that's my impression, my idea.
Thanks, Milan. Ladies, do you have something to add?
So I don't teach in business analytics, but then in general, like say MBA programs, they are, as Milan pointed out, they are using it's like happening crazy, vibe coding tools to build stuff. And that allows them not only to analyze data, but also to show their ideas, to showcase their idea, building prototypes. That's what I've seen happening.
My answer would be to look into agents. So this was Raji's last point. So if you use ChatGPT, you can use agents now to buy you groceries. I'm running an experiment of sorts for me, sort of ethnic foods. Where can I buy my favorite foods from my childhood? And ChatGPT is pretty good at finding the stores that took me like 10 years to find in the Bay Area, and almost doing the shopping for me. So I think this is a question of where business analysts, another way to think about this is, will there be a profession? Is that a profession, a task, a business analyst anymore, or is it an agent doing that analysis? So just looking to the future.
Yeah, very cool topic that you were saying now, Rita. I mean, where to find the food from the childhood. I mean, that is really something that you wouldn't come like at first to think about. Thank you. Then we have another question for everyone. It's another ethical question. So from an ethical standpoint, how safe is it to share research data or files with AI tools when working on academic projects? It's a question for everyone again, however you prefer, in whichever order.
I can go first, and I do not. We have a data set that's confidential, and so you could create a project. I'm still very hesitant, so we are anonymizing everything. So I would be careful unless you are working in a closed wall environment, sort of proprietary models, which most of us are not.
Thanks, Nan. Milan, do you have something to add on the topic?
It's definitely some,
Oh, sorry.
yeah, it's definitely a
Yes, Nan
concern
started, yeah.
to think about, especially about what tools, what's their contractual terms to you, and what data. And there was an earlier question about IRB, so it's difficult. That's why my answer to that question was like only about what IRB's principle is, because really varies by context.
We can mention the IRB question because you already answered it privately, so it wasn't kind of said out loud. So let me just find it. I can bring it back again. Let me see. So it was a question actually for all panelists. What are the IRB considerations for using AI and machine learning based research methods, tools, or analysis? So we can maybe combine it with this question.
I think Milan was trying to say something just now.
Huh?
Yeah, I was gonna say, I think that there's like to Rita's point, you making a partnership with somebody, you might not feel comfortable sharing their data. There's confidentiality concerns. I don't necessarily think that data will do anything, but I do think that, you're making deals with somebody that you're not gonna, they're giving you their data, they're assuming that it'll be kept safe, that it's not gonna be shared wherever. And so I think that will likely dictate a lot of these relationships. I think sometimes that's where a lot of these, smaller models and models you can run on device can help, because unless you really need the model that does everything, if you need a model that does a very specific thing, you can get a model for that. You can use that, and you can probably run that locally, and so overcome some of these privacy concerns. But I'm not concerned that, you know, now they're going to have this brilliant information. What I'm concerned about is that you've just violated a kind of agreement you've made with somebody, which is give me your data and I'm not going to just upload it randomly to places on the internet.
And some universities have AI playgrounds that are, I don't know how up to date the models are, you know, not always maybe up to date, but that would be a safer place. And that's why they've been creating.
Yeah, thank you all. We have time for one more question. Oh, Herman is here. Herman again is he's thanking everyone for excellent presentation and leading the field regarding these critical issues. So thank you, Herman. We have one more last question from Orkun. It's a little bit tricky one, and I think we would also like to know the answer to these questions. It's for all the panelists. If you could predict kind of the future of publications on AI in AOM journals. So which topics will be emphasized? Which are kind of the hot topics for AOM journals when we talk about AI, in your opinion? For all of you.
I'll just share mine. I think that I think currently there's a lot of enthusiasm as AI as a thing because it's fundamentally changing so many different processes. So it's like how AI is changing a current process. My sense is that in the future, it will be just studying that process and AI will be a part of it, right? It'll be like, you know, studying communication or management or whatever. And you're not going to assume that like managers don't have email. You will assume that it is one of the tools that they use as part of the frame. So that's my take.
So some research study, like, so AI can be used as a tool. You know, you like Milan pointed out, you're looking at something else, and AI is a tool, or AI itself can be the substantive subject matter. I guess to either situation, the first case, it is becoming a very effective tool that people are exploring and experimenting, and that will push the frontier of science. And we'll predict like there's a powerful tool here to enhance science. It will be used, but then there will be a lot of discussion about the safeguards and then all these the guardrails. For the second one, because we are applied field, I think what we care about also reflects what societies care about, what a business society care about the role of AI in a variety of things. And my prediction would be that things that are really the pressing answers that business world and society wants to answer, they're also important topics for this community.
And my hope is that we've seen so many interesting AI machine learning methods today that we are using the methods and the learning to study interesting topics. And my prediction is that we will see many more AI agents as part of human teams and taking over some tasks that we previously did. And I think that's an interesting content question for AI. Where will this, multi-agent, these agentic organizations, where will they go? And of course, we use the methods that we learned today to study them.
Thank you very much, Rita. Milan, do you have something to add? Because I see the mic still on. Okay, that stayed. I think this was a wonderful wrap up kind of everything we spoke about today. We have one last minute, so thank you all for joining us today. And of course, special thanks to our panelists for sharing such thoughtful and I would say very concrete insights. I mean, we see now how AI can enhance our research methods, but also how important it is to use these tools actually with rigor and care. And we talked a lot about kind of ethical topics as well. So I hope this session inspired also new insights in your own work. Have a great rest of your day if you're in the US. Good night to my fellows in Europe and everyone joining us further east. Thanks everyone once again. All the best. Bye.